Here's a data set that we could analyze from 2011 motion picture data. It's 100 movies that were released during the year. It has variables for opening gross sales, which is the sales on the premiere weekend, typically Friday, Saturday, Sunday, and the sales that occurred during that opening weekend. The total gross is the total gross after in the case of Harry Potter, the 19 weeks and released in 4,375 theaters, the total gross was $381 million. There's 100 of these movies released in 2011, and they're rank ordered by total gross sales. And this allows us to kind of see how each of the movies did during the year. One of the things we'd like to do is some descriptive statistics. We have 4 variables, 2 of which are continuous. The other 2 are discrete variables, but they're all 4 quantitative. If they were qualitative or categorical variables, we'd have fewer options in terms of the analysis that we could do. Excel stat will count categorical variables and do whatever statistics are available for them, but we mostly have a lot more options with quantitative variables. So that's what we're going to do. We're going to do descriptive statistics. We're going to use Excel stat to do that, and the tool that we'll use is under the describing data icon here, descriptive statistics. The symbol is X bar, which is a symbol for a sample mean, but it is used to indicate descriptive statistics will be performed. When we select that, it brings up a dialog box. We're going to clear out any existing data that's there by hitting the little reset button here, and it clears out all the data that was in there previously when the problem was done using this feature earlier. And then we select our quantitative data. We can also have qualitative data that we can select, and we can also select based on categories or subsamples. If we had that in this data, we could actually group them in a subsample, similar to what a pivot table would do in Excel. So let's select our quantitative variable, including all the labels. So the outputs will be appropriately labeled based on the variable names at the top. We'll make sure that the sample label box is checked right here to indicate that the data does include a sample label in the first row of each column. We then select where we want the data to be, data output to be placed in the workbook. We can select the range within the current sheet. That's typically my preferred place to put them because it's right with the data, but sometimes the worksheet can get so cluttered with all the stuff that's there that you might want to put it in a separate worksheet. I'm going to put it in cell G1, or at least it will start there and be done. I can also put it in another worksheet within the same workbook, or I can create a new workbook and have it put in that workbook. If I create a new sheet, it will create another tab down here on the line, and it will be colored to show that it's related to the data set that's here. It'll tell what it is, but we're going to put it in the range here and let it put all the output there what we select. The next tab in the dialog box is the descriptive statistics, or the options tab, excuse me, and it has the descriptive statistics and charts already checked. I can standardize the data here. I don't want to do that in this case, or I can rescale the data from 0 to 100. I don't want to do that. It also has a confidence interval elected here where an alpha is equal to 0.05, so the confidence interval percentage would be 95%. We'll not need it for this demonstration. Next tab is called the Outputs tab, and it has two columns, one for quantitative data and one for qualitative data. We don't have any qualitative data, even though all of these are selected. We're not evaluating any qualitative data in this problem, so that box wasn't checked. Therefore, this is not available for us to select. But we can come down here. These are, you may, when you first open it, have all of the different descriptive statistics selected. I've selected only those that I think are appropriate for the problem, things that we normally use. And I select the number of observations, the max, the min, the max, and I'm going to add the range here. I also get the first quartile, the median, and the third quartile. By selecting those three, and max and min, I get a 5-number summary, and it helps describe the data and show the range of how the data is spread, the shape of the data. I also select the mean, and because this is a sample, I select variance for n-1 and standard deviation for n-1, because again, it's a sample. If I had the whole population of all movies released, then I would select variance n and standard deviation n. I'm going to select the variation coefficient, which is the ratio of the standard deviation to the mean, and it gives kind of an appreciation of how big that standard deviation is. And I'm also going to select the this skewness factor, Pearson skewness factor, that will give us a sense of whether or not it's skewed. Let's see. And all of these other various descriptive statistics are valuable for different kinds of problems, and we don't need them at this time, but you can come down and look at all of the things that are available under descriptive statistics. The next tab is the charts tab, and we can select what we want to display. We're going to display the box plots. Again, that will give us a sense based on the first and third quartiles, the median, and the outliers. This will give us a visual of how the data is spread. We'll select the options here. It'll display the box plots in a vertical way, and I'm going to have it identify outliers, and we'll have that show up in a visual graph for each of the variables. So now that we have all of our variables selected, columns B1 through E101, where the output is going to start is in G1, and all my descriptive statistics and the charts and the outputs that I want for display, I am ready to click OK. Clicking OK gives us the outputs that started in cell G1, and here they are. Here's our descriptive statistics for each variable. ExcelStat does not format the tables that it presents, so you have to be able to see all the labels, you have to expand the columns so that all the labels are clearly visible. And so here's the opening gross sales, total gross sales, number of theaters, and the weeks in release. And here are their descriptive statistics. All of them have 100 observations. And here's the min for opening gross sales. Notice it's in millions of dollars for, so this is $70,000 is what that is. Here's the max is $169,000 or $169 million. That was the Harry Potter movie. Here's the range of the opening gross sales, goes from 0 to $169.12 million, about 0. And then here's our first quartile, our third quartile, and our median. The mean of the data is 27 million bucks for the opening gross sales. Here's our variance in dollars squared, the standard deviation in dollars, and you can see the standard deviation is 26 million. So that's a pretty large number compared to the mean. So its variation coefficient is 0.959. So that's a very large standard deviation. and here's our skewness factor 2.842 for opening gross, which means it's highly skewed to the right. And this would variables or values over 1 would indicate it's highly skewed, and the same is true for this for the total gross sales as well. And so each of the variables have the respective descriptive statistics that are used to describe the data. Underneath them are the box plots, and for each variable, opening gross, total gross, number of theaters, and weeks in release. Here's the bottom of the box is the first quartile. The line is the median. The red plus sign is the average, and you can see that these outliers tended to pull the mean above the median. This is the third quartile, and this is the interquartile range. The third quartile minus the first quartile gives the interquartile range. The whiskers on the box plot show the boundaries of the outlier range. Anything outside of these boundaries are outliers, and the ones marked with X tend to be extreme outliers. And so they're moderate outliers and extreme outliers, and you see you have them in the total opening gross and total gross, and you have outliers in the opposite direction for the number of theaters. So you have some that were released in less than 1,500 theaters, and these are considered outliers. The preponderance of the data is between the first quartile and the third quartile, and it's between about 2,800 to 3,549 in terms of number of theaters that they were in, the movies were released to. And so you can get a sense of the range of the data by looking at the first and third quartiles. And the last one is this weeks of release, and some were extreme outliers were around 43 weeks in release. This extreme outlier here. If you hover over each point, you can see what the point is referring to. So this is 30 weeks in release, and this one is 25 weeks in release. And so you have these three outliers in the weeks in release. They tended to be between about 11 weeks in release and 17 weeks in release before they went to other markets. And so that's kind of a summary of the things that can be done with the descriptive statistics. You could also add other graphs to this. You could have stem and leaf plots and normal PP and QQ plots and those kind of things if that's part of your problem. But this is generally the kinds of things that you'll be asked about in a descriptive statistics analysis.